Hello everybody. Today we will start with a new chapter in chemistry, that is chapter number 9, carbon and its compounds. Now, carbon is a very unique kind of an element, and because of this unique nature of this, it has got so many different forms as natural carbon also and a combination of carbon also. That's why in fact there is a complete chemistry which is based on carbon compound, and that is nothing but organic chemistry. So organic chemistry is a chemistry based on carbon compound. So that means you can understand that what huge amount of different products can be made with the using carbon and its compound. So that's why carbon is a very important kind of a element. So now if I'm talking about just a general thing about the organic chemistry, so all the plastic, the nylon, the polystyrene, the the PVC pipes and all PVC, this polythene bags what you are using, polyester cloth which you are using, plastics, all the different kind of plastics, all are, even petrol, diesel, so all the different kind of the fuels, everything are organic compounds. So you can understand that how large is the variety of this particular organic compounds, right? So let's understand that what exactly do we mean by the different carbon and its compounds. So introduction, carbon and its compounds. Introduction: carbon is widely distributed element and forms innumerable compounds with oxygen and hydrogen. So that's the main thing, that carbon. So carbon has got formation with hydrogen and oxygen. So C is going to combine with hydrogen and oxygen in certain ratios and forms to give you such kind of compounds. So all the carbohydrates what we are eating, the hydrocarbons which are the fuels, all these are carbon compounds. So accordingly we can see that the carbon compounds can be distributed into 2 points. Okay, so if we talk about the carbon compounds, we can say the carbon compounds can be of two kinds. One is the organic chemicals or chemistry, and the other one is inorganic chemistry. So the chemistry, we can divide the chemistry into two parts. One is the organic chemistry, and there is inorganic chemistry. Now in case of organic chemistry, the study of specific carbon compounds, which include compounds mainly of carbon, hydrogen and oxygen, are coming under the category of organic compounds. So they are basically the compounds formed by carbon, hydrogen and oxygen. So carbon, hydrogen, oxygen, when they combine together to form some kind of different forms of compounds, then they are the organic compounds. Whereas, so examples would be methane, hydrocarbons like methane, ethane, acids like acetic acids, alcohols like methyl alcohol. All these are examples of the carbon compounds. In fact, even the glucose, that is C6H12O6, the sugar what we eat, the hydrocarbons what we are eating, all these are compounds. Hydrocarbons, you can, and carbohydrates, sorry, not hydrocarbons eating. Hydrocarbons are the fuel. The carbohydrates what we are eating, so carbohydrates, all the carbohydrates are basically carbon, oxygen and hydrogen. So carbohydrates, hydrate is nothing but water, H2O. So it is carbohydrate. Okay, so that is how it works out to be. Whereas inorganic chemistry is includes the study of oxides of carbon, carbonates, bicarbonates, metal carbides, etc. So when you're talking about bicarbonates or carbonates or metallic carbides and all, so when we are talking about the valency, when we learned in the valency chart the carbon ka different forms of carbonates ka CO3, HCO3, bicarbonate, so ye jo tha, that was coming under the category of inorganic chemistry. So in inorganic chemistry, so we know that carbon monoxide, carbon dioxide, calcium carbonate, calcium bicarbonate, calcium carbonic acid, all these are different forms of the inorganic kind of carbon compounds. So inorganic kind of carbon compounds come under this category would be the carbonate, the bicarbonate, the carbides, So accordingly, CO, CO2, H2CO3, all these are examples of inorganic compounds of carbon. So you can see, and apart from that, other compounds of carbon include sugar, starch, fuel, synthetic fuel fibers. So all these are also carbon compounds. So in this way, you can find that the carbon compounds can be mainly divided into two parts: the organic part and the inorganic part. Organic part is mainly concerned with the compounds which are formed by carbon, hydrogen, and oxygen. Whereas the inorganic part will be the one which is combining in for carbonates and bicarbonates and carbides. So all these are inorganic compounds. Of course, occurrence wise, carbon occurs in free state as well as in combined state. Of course, all we are seeing over here are the combined state. In free state also carbon exists. Okay, carbon exists in free state also, and you will be surprised that carbon exists in different forms in free state. So it is not that carbon is always that black colored thing, or it will be like even the diamond is a carbon compound. Okay, so you can see that carbon is having different forms. So yeah, in free state carbon occurs in free nature in a crystalline or crystal form as diamond, graphite, and in amorphous impure form as coal formed below the earth's surface. So yeah, the carbon will be in either a crystalline form, where that means it has got a proper geometrical shape like that of the diamond, the graphite. They've got a proper geometrical shape, and that's why they are called as crystalline kind of substances. Whereas there are these carbon compounds which are going to be amorphous. What do you mean by amorphous? The one which are shapeless. Okay, they don't have a proper shape of their cells. Like for example, we take coal. Now coal is a carbon compound, and this coal doesn't have any shape. It is just a rock. So when you are breaking it, whatever shape it is being breaking into is the shape of that particular coal. So that's why they are the amorphous impure form of coal which are there below the earth's surface. In combined form, carbon is going to be occurring in the form of carbon dioxide in the atmosphere. So we know that 0.03% of the air is carbon dioxide. So carbon dioxide is one of the carbon compound which is a part and parcel of the air available to us. It also occurs in hydrocarbons, in natural gas and petroleum. So all hydrocarbons are basically fuels. The ethane, methane, butane, petrol, diesel, kerosene, all these are the wax, wax also. So all these are the fuels, and these are called as hydrocarbons. So all the hydrocarbons contain carbon in a combined form. In the solid state, it occurs in wood. Yeah, wood is also a cellulose form, which is also a kind of a carbon compound. In plants and animals as hydrocarbons, we know that carbohydrates. Oh, sorry, I'm just getting misunderstood. Okay, so carbohydrates are the one what we are intaking as food. So the starch and everything are the carbohydrates. So in plants and animals are carbohydrates, and in minerals as the carbonates like limestone is calcium carbonate. So in this way you are also having the carbon in the form of minerals in the form of calcium carbonate, which is nothing but limestone. So in this way you can see that carbon is going to be occurring in free state as well as in case of the combined state in nature, as well as in air, in the minerals form, and also in the combined form in phase of solid, liquid and gases. So it is already in the form of gas in the air as carbon dioxide. It is there in the liquid in the form of petrol, diesel, kerosene, etc. And in the case of the solid, it is there in the form of calcium carbonate or any carbonate in such, sodium carbonate, any carbonate which will be going to be present in the earth's crust. So in this way carbon ka occurrence ho gaya. Now we are going to see the different forms of carbon. Now carbon has got a very peculiar nature that it is going to be available in different forms, and because it is available in different forms, we call this different forms. So whenever any particular element is such that it is available in free state in different forms, we call it as the allotrophy. It is allotrophy. Okay, it is allotrophy of carbon. So allotrophy of carbon means carbon present in the nature in different forms. Okay, so when we see that existence of any particular element is there in different forms, we call it as the allotrophy. Okay, so in case of definition of allotrophy, we say allotrophy is the existence of an element in more than one physical form. If any particular element is available in more than one physical form, we call it as the allotroph of that particular element. So, one thing is, it has got more than one physical form. The second thing is having different physical properties. So, not only that they are having different forms, like suppose I say that water vapor and water. Now, they are not allotrophs. Why? Because they are, of course, they are in different physical forms. But the properties of H2O and the properties of the as a liquid and a gas are not going to be different. So here it is having different physical properties are there, but the same graded chemical properties. Okay, so here we see that, okay, we know even in water is the same thing, that is different physical property, but it has got the same chemical property. So here also same graded chemical property is going to be there. So similarly, any particular allotroph means any particular element which has got different physical forms, has got different physical properties, but has got similar chemical properties. Okay, so this is the three things what we are connected to allotrophy. So that's the definition. Allotrophy is the existence of an element in more than one physical form, having this different physical properties but the same graded chemical properties. Allotrophs exhibit different physical properties but the same chemical properties. Allotrophy is a result of the difference in atomic arrangement in the crystal structure of the element. Hence, they differ in physical properties but are forms of the same element carbon, and hence they have similar chemical properties. So, irrespective whether the carbon is going to be placed in such a way that it forms into a crystalline form, or the carbon atoms are placed in such a way that it is forming an amorphous form, but the chemical property, that is the valency of carbon and all, remains the same, and that's why the chemical properties of the carbon is going to remain the same, but its physical form is going to be different. So that's what they are saying, that allotrophy exhibits different physical properties but the same chemical properties. Allotrophy is the result of difference in the chemical atomic arrangement. So the atomic arrangement in case of the carbon is different for different kinds of allotrophs of the carbon. So it is atomic is in a crystal structure of the element, hence hence they differ in the physical properties. So since the crystal structure is different, so their physical properties are different, but they are the same element are of the same element, and hence the similar chemical properties. So the same element means they have got the same valence electrons, they have the same electronic configuration, the same number of protons and electrons. So therefore they are going to have the same kind of chemical properties. So we see that the allotrophs of the carbon can be broadly divided into two types. Okay, what are the two types? The first thing is, one is the crystalline form. So first one, it is in crystalline form, and the next one is amorphous. So I just discussed this earlier with you all, that the crystalline form is the one in which it has got a proper geometrical shape. The elements, the carbon atoms are connected to each other in a form which is a structure, which is a pure geometrical shape, and that's why they are called as crystalline. Whereas if the atoms are going to be randomly placed in such a way that they do not form any kind of a geometrical shape, then it is called as an amorphous form or microcrystalline form also. So in case of the crystalline form, there are three products, or we can say the three different kinds of crystalline form. The first one being diamond, the second one being graphite, and the third one is Fullerene. Okay, so Fullerene is the third one. Diamond and graphite you must have heard quite commonly, because diamond is of course the jewelry industry, and the graphite is the one which you are using for pencils and all. The pencil ka lead वगैरह जो है, that is made up of graphite. Yeah, Fullerene you may not be aware about, but that is a kind of a carbon compound. So diamond, graphite and Fullerene. Fullerene is a hollow cage form of carbon having about 30 to 900 atoms in one molecule. So when there are multiple number of atoms forming into, now normally the Fullerene is in a form of a ball shape. Okay, it's in a ball shape. जहाँ पे एक छोटा सा ball भी बन सकता है जहाँ पे 30 atoms of carbon है connected to each other, and the other one could be such that it is huge. It is almost like 900 carbon atoms combining to form one particular molecule. So in that case, Fullerene will be right from 30 atoms in a one molecule to 900 atoms in one molecule. Buckminster Fullerene C60 is a spherical form of carbon containing 60 atoms in its molecule arranged in the hexagonal and pentagonals. Hexagons and pentagons. It can be obtained by condensing vaporized graphite. So now this is a particular kind of a Fullerene. Now this is a Buckminster Fullerene, which is, I would say, the Fullerene. The shape of this Fullerene is made up of many pentagons and hexagons. So hexagon and pentagon connected to each other, they form into this particular Fullerene in a ball shape, exactly similar to a football over there. If you see the football has got pentagons, and there are many pentagons all connected together to form the whole ball. So वैसे ही अगर हर एक पेंटागन का एक वर्टेक्स पे अगर एक कार्बन एटम है और इस तरह से अगर वो बॉल बना है, so that will be a Fullerene. So this is Buckminster's Fullerene. Now in the amorphous form, they are basically the different kinds of charcoals. So the charcoal which is there, so the different kind of coals are there. So the first one over here, the first one is the different kind of charcoal. So charcoal, which is one sec. Now charcoal is of, over here there are 4 types of charcoal. So charcoal is in different forms. So there are 4 kinds of charcoal, 3 types of charcoal which are given over here. First is the wood charcoal. The second one is the sugar charcoal. And the third one is bone charcoal. So these are the different kinds of charcoal which are present. Now we will learn in detail about the different kinds of charcoal which is there over here. So that's charcoal, and apart from that there are, one is lamp black. Okay, there's a lamp black over there. Then there are different kinds of coal, and finally there are the coke. Now all these are different things. So coal is found in the ground, coke is also formed by the different forms of carbon, and lamp black is a powdery form which we'll learn in detail in the next part of the chapter. So so this is how the allotrophy of carbon is being placed. That it is, the allotrophy means, as I told you, different physical forms but same chemical properties. So it can be of 2 types: crystalline form, that is a proper geometrical shape in which there is a diamond, graphite and Fullerene. Amorphous form, there are 4 different kinds of amorphous form, means that is they don't have any shape, the proper shape. Okay, so in that they are charcoal, lamp black, coal and coke. In charcoal there are the, depending upon charcoal is made up of what particular kind of material, whether it is made up of wood, then it will be wood charcoal. If it is made from sugar, it will be sugar charcoal. If it is made from bones, it will be the bone charcoal. So in this case, in this way, these are the amorphous forms of the allotrophy of carbon. Okay, now we are going to study the comparative study of the first 2 carbon compounds, diamond and graphite. So here we are going to study that how the diamond and graphite are different from each other, but at the same time there are so many common things between them. Like, of course, both of them are carbon compounds. So we are going to see in detail about the diamond and graphite. So first of all, we'll just go for the diamond part and then we'll go for the graphite part. So first of all, let's see the first allotrophy of carbon, that is diamond. Of course, everybody has seen diamond, so nothing new to you. So first of all, occurrence wise, we know that it is available in the ground surface. Okay, it is in the earth's crust, that is as an ore. So occurs naturally embedded in hard rocks found in many parts of the world like Africa, Brazil, and also it can be prepared artificially by subjecting pure carbon to high temperatures and pressure. So when basically the carbon, when it is deep into the soil, it is, because it is very deep inside the soil, there is too much of the pressure and temperature from the core of the earth which is applied on that carbon. And when that particular high amount of pressure and temperature gets applied on that particular carbon, the carbon, it gets shaped into a specific kind which is nothing but diamond. So yes, if you are going to apply very very high temperature and very high pressure to carbon, you can artificially produce diamonds. So diamond is as such naturally occurring, but also it can be prepared artificially by subjecting pure carbon to very high temperatures and pressures. Structure of the diamond. The shape of the crystal is a three-dimensional octahedral 8-sided crystal. So it is an 8-sided crystal. Now when it is an 8-sided crystal, it could be such that it could have one base and then 7 tops on it. Okay, so it will be 7 shaped. The 7, it will be a heptagon, or basically what they call it as an octahedral. Okay, so octahedral means nothing but 8-sided figure, and then there will be the triangles to form a pyramid sort of thing. They are given the example of this particular, or it could be 2 4-sided figures, one on the other. Okay, so if one sided here and one sided here, one is like this, one like this, so forming into a diamond shape. So accordingly, it will be a 3-dimensional octahedral 8-sided crystal. Now the crystal lattice is built up from a 3-dimensional tetrahedral unit. So it is going to be a tetra means 4. Okay, so it is 4-sided figure. Okay, uske upar hedral means forming into a pyramid shape. So tetrahedral unit which is there, which is 3-dimensional, and in this unit of carbon atom is linked to 4 other carbon atoms by covalent bond of equal length. So basically what happens is there is one carbon, another carbon at a distance exactly similar over here to this distance and this distance and this distance. This is connected to another 4 of them, then this connected to another 4 of them. ऐसे करते करते each and every carbon is connected. So it's over here. If this is one carbon atom, okay, it is connected over here, over here, over here, and over here with 4 carbon atoms. Okay, and then this again is connected to 4. So this is already 1. There is one over here, one over here, one over here. ऐसे करके यहाँ पे भी 4 आएंगे. ये again it is connected to 4 of them. So over here, and over here. There is C over here, C over here, C over here. This also can be interconnected like this. So ऐसे करके करते करते you are going to form into a structure. So this is how the lattice of the carbon are linked together. The covalent bonds are directed towards the apex of the regular tetrahedral. So it so happens that all these is connected in such a way that it is going to be at the bottom, and then it connects upwards to the tip of the thing. So this forms into a proper pyramid shape. That is why it is called as a tetrahedral structure. So the covalent bonds are directed towards the apex. So apices, that is nothing but the topmost point, apex of a regular tetrahedral. So what they are shown over here is the dots which are there in the figure are nothing but the carbon atom, and the lines which are there are the covalent bonds. So this I have given you as C. Actually what they have done is just colored this two complete dark circles over here, and then these ones, these single lines over here are the covalent bonds. Okay, they are single covalent bonds. Covalent bond means they are sharing the electrons with each other. So this carbon and this carbon are sharing one electron each with each other. So that's how it is going to form into a covalent compound. Right? And now we talk about the graphite. I'll do one thing, I'll just continue with the graphite part and the further part in the next video, so that there is no confusion. Right? Sure. Oh, not required. I can easily continue. I got just more 5 minutes in this video, so that I can easily explain the graphite part also. So you can see the next thing what we are having is the main introductory part of the graphite thing. Okay, so what is graphite and how is it made up of? So when you talk about graphite, so occurrence wise, again naturally occurring, it is as plumbago. A plumbago is nothing but the simple kind of a black solid found in the different parts of the world. Prepared artificially by thermal decomposition of silicon carbide. If silicon carbide is heated, it is going to decompose into two parts, and that will be carbon. What we'll be getting from silicon carbide is nothing but graphite. Structure wise, the shape of the crystal are two-dimensional sheet-like flat layered crystals. So here what happens is that the crystal, the carbon is connected to each other in a flat thin line. Carbon connected to in the thin line. Another carbon करके एक पूरा दूसरा शीट, तो एक शीट बना, फिर ये दूसरा शीट बना, और ये दोनों शीट ऐसे एक के ऊपर एक है, and they are connected to each other. Okay, so you can see the figure also gives you a sheet and then there are connection between the two sheets. So the crystal lattice is built up from a two-dimensional hexagonal unit. So there will be hexagonal unit, so they will be forming into a hexagon. So 6 carbon atoms connecting to form an hexagon, and such hexagons का एक पूरा का पूरा एक sheet बनता है, और वैसे दूसरा नीचे और एक sheet बनेगा, and these two sheets are connected to each other. उसके बाद और एक sheet ऐसे करके layers में. So graphites are always in layers. The graphite is always in layers. In this unit of a carbon atom is linked with 3 other carbon atoms by the covalent bond in the same layer. So one carbon is connected to 3 others in the same layer. ऐसे करके पूरा का पूरा spread है. चौथा वाला जो है वो एक को दूसरे के साथ लिंक करता है. ये लेयर को ये लेयर के साथ में लिंक करता है. That is the fourth bond, because see, carbon has got valency 4. The valency of the carbon is 4, so it requires 4 electrons to complete its outermost orbit. So 4 कहाँ से मिलेगा? तो 3 is on with the carbon in the same layer and 1 in the next layer. ऐसे करके it is connecting into a covalent bond. The layers are arranged in parallel, one above the other, held together by very weak van der Waals force. So these two layers are connected to each other by covalent bond, and this bond, what is going to be there, is called as a very weak force. It's a very weak force, and this very weak force is called as van der Waals force. Okay, the van der Waals force is a covalent bond. The force of attraction with which the two electrons are bonding with each other, or 2 atoms are bonding with each other by sharing of electrons, are the van der Waals force. So this is what they are given over here in the figure, that hexagon के साथ में पूरे का पूरा एक sheet बना है carbon का, so that is layer of the graphite. Another layer of graphite with another hexagons connected together, and then these two are connected with each other by a weak van der Waals force between the 2 layers of the graphite. Okay, so this is how the arrangement of the carbon atoms is there in graphite. So yes, this gives you the example or the idea that how the formation of diamond and how the formation of the graphite takes place. Diamond, it was a tetrahedral structure, so it was like this कि यहाँ पे ऐसा tetrahedron बना, और उसके बाद में they are connected to the top exactly over here. So this is the connection what you are going to have in case of diamond. Whereas here it is the hexagons which are going to be formed over here. There are different kinds of hexagons which are going to be there, and these hexagons are going to be connected to another hexagons which are over here. Okay, these are another hexagon and these are connected to each other. So this hexagon connected to each other. ऐसे करके they are connected to each other to give you by simple van der Waals force, so that there is a very weak force which is connecting the 2 layers of the graphite. So this was about the general kind of a structure about the diamond and graphite. In the next video, we will see the physical properties and chemical properties and uses of the diamond and graphite.